Number 6.
Consider the graph of the function f of x equals negative x squared minus x plus 6.
And then it says to find the equation of a secant line joining the points. The fact that I'm saying secant line and giving you 2 points, that's being redundant because we know secant line is automatic 2 points. And we want to find the equation. If y'all remember finding the tangent line, we had to find the point, and then we had to find the slope. So on our point, it doesn't matter which point we start with, but let's go ahead and find our slope first. The slope for this one is secant is a rock. And our average rate of change basically is y2 minus y1. I think I'm going to write a rock here one more time. Do y'all need me to label these?
Yes, that'd be nice.
X1, y1, x2, y2. So it's y2 minus y1, which is 0 minus the what? 4. And x2 minus x1 is basically 2 minus the negative 2 is basically positive 2. And what would that slope be? Negative 1. So we have our slope. Let's write out y minus y1, the skeleton model of the equation. When given 2 points, does it really matter which point you are going to use? No. Which one seems easier? So I'm going to go ahead and use 2, 0. If you use negative 2, 4, we're going to end up with the same equation, which is fine. So we have y minus a 0 is equal to negative 1 times x minus a 2. And since that 0 is not really relevant, I can simply say y is equal to negative x plus 2. This is the equation of our secant line. So let's write out secant line. Everyone good with that one? Okay, Ian, let's read part B. So let's restate the mean value theorem. It says I rock is equivalent to what rock? A rock. And we know I rock is coming from the equation. Here's my equation right here. So what is the derivative of that equation? Negative 2x minus 1 is equal to the I rock that we just found, negative 1. And when I do my tedious algebra 1, we get x equals how many? X equals 0. And then according to our definition, ideally a c is equal to 0. But do I really care? Nope. So we determine point C. If the point C is at 0, they're going to be parallel to each other. Let's go to the next one. Find the equation of our tangent line. Let's write point and slope again. Point and slope. And for this one, it is equation of a tangent line. So that means the point that we are going to use, it says if the point was 0. So let's plug in our slope into our slope equation. We have f prime of x that we found was negative 2x minus 1. So I need to plug in the 0 into my x. So we get f prime of 0 is equal to negative 2 times 0 minus 1. So what is our slope for this one? Negative 1. What about to find the y value? What do I need to do? I need to go back to the tangent line. So on our tangent line, we need to go ahead and plug it in. F of 0 is equal to negative x squared minus x plus 6. And there's a reason for me not to plug in the 0. Since we're looking at 0 for the x's, isn't the y value basically the y-intercept? 6? Because no matter what you plug in, as long as there's 0, your y-intercept is going to be the y value. So then let's go ahead and plug it into our point slope formula. So we have y minus a y1 is equal to the slope times x minus a 0. And when I do solve for y all the way, we're going to get negative x plus 6. And that is the equation of our tangent line. So let's write it right here, tangent line equation. Now, here's a given fact. Is it okay that my slopes are identical? Yes, they have to be, because they have to be parallel. And they have to be from two different points, one through 2 point, one through 1 point. Right, Luke? Falling asleep? Wake up. So let's actually graph this. And I want to graph by starting with our equation, which is f of x. So I can prove to you by the picture. The original equation says the following. Oh, I know I just made a mistake. That should be a negative. And let's plug in some numbers to see what the graph is going to look like. Now, does it matter what numbers to write on your x's? Hopefully your numbers are one of these, right? Okay, so I'm going to go ahead and say -3 is a good number for the following reason. When I plug in the -3 into the original, that is actually going to give us 0, I believe. Let's double check. 9, -9, +6, and +3. Yep. So we have -3, 0. Should we go ahead and plot the 2? -2? Yep. Let's plot these 4 points with the neighbor and tell me what the y value is in about 40 seconds. Is it fast? Give me at least half. Hopefully Yana 0 is 6. We did that one already. The original is +6. Apparently, I don't know how to copy. You know. There you go. Whoever said that, thank you. So what is our output when the input is -2? Uh-oh. -2? Did someone say 4? What about 1? And really, I meant to write -1. That's my mistake. If we plug in -1, what should we get?
-1 you should get. I got -4. I do wrong.
Girl, I don't know. If you can't plug it in, I'm not showing that part. 6. And if you plug in 2 is 0. So I'm going to go ahead and plot this. -2, 4. -1, 6. 0, 6. And then I think because it's a parabola, can I kind of mirror the other side by saying it should be here? It should maybe be by the mirror over here. So let's go ahead and graph this. And I'm only graphing to prove to you, since seeing is believing. All right. So we found the secant line and the tangent line. So I'm going to go ahead and graph the secant line first. The secant line is -x plus 2. So +2, down 1 over 1. So the graph does something like this. It's our secant line. And then let's graph the tangent line. Says our y-intercept is 6 and down 1 over 1. And the graph is doing something like this. So here's our tangent line. So have I proven to you that those two lines must be parallel by the mean value theorem? That's it. We did all that just to prove to you that they are physically parallel, in case you're having a hard time looking at the equation alone. All right, the next page is our last piece for today. So we're going to jump around to extreme value theorem and intermediate value theorem. And I think first one we're going to use is the intermediate value theorem. All right, for number 7, Dylan, let's read.
The figure shows two parts of the graph. graph of a continuous differential function of f on -10 or the derivative of f is also continuous.
So let's underline it's got to be continuous and differentiable. So let's write out our conditions. There must be no cusp. There must be no hole. And there must be no what?
Vertical asymptote.
Good, vertical asymptote. So I gave you the starting point of the graph, and I'm also giving you the end point. What you do in between doesn't matter as long as you do not pick up your pencil. All right? So I'm going to be that boring person and do this. I'm not very creative. Now, you could have gone dramatically up and down, curve whatever you want, as long as it's continuous. So let's write everything about this. Part A says, explain why the function must have at least 1, 0. So let's underline that phrase. Why the y must equal 0 at some point. Just by looking at this, have I gone through y equals 0 at some point?
Yeah.
Yep, at some point I did. And that should have gone through the origin, but that's okay. And which one tells me that there must be something of the y equals 0? Extreme or intermediate value theorem?
IVT.
IVT it is, because if I give you the high end and the low end, there must be some number in between. So let's go ahead and mimic this. The first thing that we're going to mention on this one, well, let's write IVT as our side note. So let's write out our conditions. The function is continuous on the interval of -10 to 4. And yes, I'm mimicking what I have on the card. And then I need to find out, well, what are those endpoints and what are the values? So we know the other one is f of -10, and then we have f of 4. And I want to look at this into the graph. At f of -10, I know it is not 0, I know it is not 2, but I want to be safe and use whole number. What whole number is appropriate?
1.
1. If you want to write 1.2, that's okay. Now go to f of 4. Same idea. I know it has to be less than -2, greater than -4. I want to use a whole number. -3 okay with you guys?
Yeah.
So does 0 really appear between these two numbers?
Yeah.
Yes, it does. So let's write this in a inequality form. -3 is less than 0, less than 1. And specifically, f of 4 is less than 0, less than f of -10. And what was the symbolic notation for therefore?
The 3 dot.
The 3 dot, 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 dot. And I'm going to write by the intermediate value theorem, the function must have a 0 on -10 to 4. In that phrase, I'm literally copying what is on part A. And I'm not even write the word at least. You can. You'll still get full credit. So this is simply review from Unit 1. So why not throw it out there for you? All right. So is everyone good with the reminder from Unit 1?
Yeah.
All right. Let's do another reminder from last week, actually. And we're looking at extreme value theorem. Castro, let's read part B.
Explain why f prime must also have at least 1 0 in the integral -10 4. What are these zeros called?
All right, the f of prime must have at least 1 0. Let's do a recall. If f prime is equal to 0, the prime is basically what function? Slope? Thank you. So we know there must be a slope of 0. So just by looking at this, we know we have to use extreme value theorem, because when I give you the extreme high and extreme low, that's when the loop happens. And that's also where the slope is equal to 0. So let's go ahead and write out something. Let's see if we had a condition. Yeah. So by extreme value theorem, the function has an absolute. Now, just by looking at this, do I have absolute minimum or maximum? For my boring graph.
That's a maximum.
Maximum. So let's go up here and write out our f prime is equal to 0, which means our slope is equal to 0. This is our relative maximum. And because I made a boring graph, This also happens to be absolute maximum. So I'm just going to describe that on my reasoning on part B. The function has an absolute maximum, also called the relative maximum, and the function, the f of f prime is 0. So all I did was redefine EVT by the picture I have, and it really depends on how creative your picture was.